we talk about the properties of acids and bases. Let's start with acid properties. We call acids proton donors. Remember, you're identifying acids typically because they start with H, there'll be some anion, and if we put them in water, what they contribute to that solution is H plus and also the anion. Now H plus, so just think of hydrogen, and hydrogen is atomic number 1, which means it has 1 proton in its nucleus. It has no neutrons if it's normal hydrogen protium. It also has an electron. But what we're doing with acids is this electron is taking off, and all we're left with is that positively charged proton, so we call acids proton donors to that particular solution. Acids increase the concentration of hydrogen ion, and they decrease the concentration of hydroxide ion. And we've shown you this before. The way that acids decrease the hydroxide ion concentration is they combine with hydroxide, the H plus does, and it makes good old H2O, and thus it decreases the concentration of hydroxide. Reacts with hydroxide to form water. They have a sour taste, so if you taste something like a lemon, now absent of food that are citric foods, oranges, things like this, absent of things like that, I don't recommend that you use taste as a measure of finding out whether something's an acid or not. For instance, I would not taste hydrochloric acid. That's a bad idea. So don't do this. We don't do it in the lab, and you don't want to do it at home either. And acids can be corrosive, particularly to some metals. So if you take a metal like iron and you put it in some hydrochloric acid, you're going to get 2 products out of that. You'll get a salt, which is, we'll just keep it fairly simple. This is iron 2 chloride. And you're going to get hydrogen gas. And so we can go ahead and balance this. That's going to give us, we've got 2 chlorines, 1 iron, 2 hydrogens, 2 hydrogens. Well, that actually wasn't too hard. Acids are corrosive for some metals. Continuing with acids, they react with organic dyes to yield a color change. Blue litmus paper turns red in the presence of an acid. There's also universal litmus paper, which is tan in color. It will also turn red in the presence of an acid. Let's talk about base properties briefly. Bases are called proton acceptors. We can do that in the same way that we described acids being proton donors. If you put hydroxide into an aqueous solution with hydrogen ion, what the hydroxide does, reacts with the hydrogen ion to make water. It's the same reaction. It's just that now you're putting hydroxide into solution to react with the hydrogen ion. Proton acceptors, they decrease the concentration of hydrogen ion by increasing the concentration of hydroxide ion and reacting with hydrogen ion to form water. They have a bitter taste. Now again, I would not recommend using taste as your detection method for bases. In times past, before things like litmus paper and easy detection methods, chemists did use taste as a test for acids or bases. Now, not so much. They are corrosive, or they can be corrosive. You can dissolve some metals in bases. They react with organic dyes to yield a color change. Red litmus paper will turn blue in the presence of a base. And again, the universal litmus paper will turn from tan to blue in the presence of a base. So bases turn litmus paper blue. Neutralization reactions, we're talking about acid-base neutralization reactions. We've spoken about this before. If it's a strong acid and a strong base, you're going to get a salt and water. Let's just take a look at a typical strong acid. This is a strong acid, HCl, and a strong base. Here's your salt. Water is the driving force for this reaction. It is a non-electrolyte, and it pulls from solution hydrogen ion and hydroxide ion. If we dissociate all of the strong electrolytes, this is called the complete ionic equation, and we identify the spectator ions. Here are all the spectator ions, chloride ion and sodium cation. They're ions on both sides. We throw them out, and what we have is the net ionic equation. This is your net ionic equation, and this will be the net ionic equation for any strong acid, strong base reaction. This is what's really going on in a neutralization reaction. The H plus is being neutralized, and the OH minus hydroxide ion are both being neutralized in this neutralization reaction, which is a metathesis reaction.